Welcome back. We're skipping section 7C, 7D for now. They're not crank and grind. They will require a little bit of reading, and we're going to hold off on that. We're going to get through the last section of chapter 7 because we like to get through the material that you guys are going to test on next. So what we're going to do is do 7E, and it's a cute little section with a couple formulas. And I think I misspoke last time, but we're going to learn how to count in this section, and then we're going to relate it to probability. And what I like to call this first thing is license plate problems. How many different license plate of a certain type can we have? Like letter, 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 and then number, 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 with no restriction of our letters and numbers. Well, there's 26 letters, and the next choice, 26 letters, and the next choice, and 10 digits, and 10 digits, and 10 digits, and 10 digits. So the total number of license plate is 26 cubed times 10 to the fourth. And get out my handy dandy calculator. 26 raised to the third times 10 raised to the fourth. So 26 raised to the third, scooch over, times 10 raised to the fourth. Or just multiply them out. Whoa, that's a lot of license plates. 1, 7, 5, 7, 6. 1, 2, 3, 4 zeros. Ooh, 175 million. Whoa, that's a lot of license plates. This is what we're studying. And I'm like, if this is what we're studying, life's pretty good. How about we go, hey, no repeat? Meaning you can't repeat a number that you used or a letter that you used. So this first slot, I have all 26 letters to choose from. This second slot, I used up one, so only got 25 left. And then the third one, well, only got 24 left. And the first digit, I got 10 choices, but I can't use that digit, so 9. And I can't use that digit, so 8. And I can't use that digit till 7. And then I like get all crazy. 26 times 25 times 24 times 10 times 9 times 8 times 7. Woo! 7, 8, 6, 2, 4, 000, boom, boom. Whoa, a lot less license plate when you put restrictions on repetition. So I call it the license plate problem counting strategy. So what we have here is if we make our selections from a group of n choices, a total of n times n times dot 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 times n are times equals n raised to the r. So what part are we working on? We're working on the problem where they allow repetition, because you see the 26 cubed, and means multiply or multiplication principle from the earlier section. Let's do it again, 10 to the fourth. So what they're going to do is try to ask us combination problems, just like license plate problems. Now, it turns out, since I did my examples before the equation that I'm actually done teaching that for right now. Maybe we should do another one. Let's just switch her up. Let's go number, 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 letter, letter. So number, 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 letter, letter, and let's just go number for some dumb reason. So if you allow repetition, 10 digits, 10 digits, 10 digits, 26 choices, 26 choices, and 10. That's with rep. And you just multiply that out, and I don't think we really care. Now, no rep, that's not what the book is talking about. At least they're not talking about it now. That's when you get 10 choices, 9 choices, 8 choices, and then 26 choices, 25 choices. Oops, 7. You can't repeat, so now 7. So this is the no rep case, and this is the rep case. So repetition allowed, no repetition allowed, and you see there's a difference. I like them both. All right, now they're going to get fancy on you. They're calling this thing permutations. Now, a permutation means no repetition. Repetition. It means order is important. And I am going to go right for a permutation formula. It's NPR formula. Now you're like, whoa, what is this? Well, it's n factorial over n minus r factorial. And that exclamation mark does not mean I'm excited about math. It actually means something. So we did the cart before the horse thing. I just told you what the formula is going to be. You don't understand what's going on, but I did use the word no repetition, so you're thinking it might be something like this. So let's practice on the exclamation point stuff. You'll love this stuff. 5 factorial, just 5, 4, 3, 2, 1. How can that not be any fun? 20 times 3 is 60, times 2, 120. Somebody says 3 factorial, you go 3 times 2 times 1. You go 6. Somebody goes 60 factorial, it's 60 times 59 times 58 times times 2 times 1 equals, I'm not doing it. You can't pay me enough. Probably too big to fit on my calculator. That's a really big number. Okay, so we don't understand what's going on. But if somebody just says 7 permutate 3, I'm in. Because that's an easy problem, because I just go 7 factorial over 7 minus 3 factorial. Don't ask questions, just do. 7 factorial, 7 minus 3 is 4 factorial, and you're about to have the most fun you probably had in your entire life. Check this out. You're going to get rewarded with the world's best cross cancellation party ever. 30 times 7, 210. Please ask me to do that. That is just math pleasure at its best. I will do that all day long. Now, when do we use it? Well, I'll tell you when you use it. Well, here's one thing. I got these 4 walls, and my wife is very particular about where we hang pictures. So, these could be picture of Taylor, my daughter, picture of my dog, Brett Favre. Yeah, my dog's name's Brett Favre. A picture of Aaron Rodgers. Wedding picture. So Tony and Tina's wedding. But here's the deal. We have 7 pictures. So my mom and dad, Tina's mom and dad, so mom S and dad S. Her last name was Schumacher. And then I'm V, of course, mom V and D, dad D. And then we need one more thing. Picture of, what would it be a picture of? What would I like a picture of? I'm looking around the house. Don't really have anything good. How about a picture of, that's my dog. Okay. Oh, like Wisconsin Badgers. Like football. I'm from Wisconsin, so don't hold this against me. I could have said a picture of a dairy cow. But when my wife has me hanging up pictures, Taylor and Brett Favre, and if I move it to be Taylor over here and Brett Favre over here, she thinks that's something different. So what my wife is saying is order matters and how I hang up the pictures. Now, can I use a picture more than once? The answer is no, because I only got one of each. So you can't repeat. So no repetition, because it's impossible to repeat because I don't have duplicates on my picture, and order is important. You know how many ways we can hang up these pictures? Well, here's the coolest thing. I just draw 4 little picture slots, and I go to myself, how many pictures do I have initially? And I'm like, I got 7, so I hang that one up. Then right here, I go, well, I got 6 left. And then I got 5 left. And then I got 4 left. And I'm like, oh, what did I do up here? Did I forget a number? Oh, yeah, we're good. So we get 20. Oh, this is hard for me. 42 times 20. Oh, I can do that. 42 times 10 is 428.40. 840 different ways. Wait a minute, Verbsky. You're supposed to be using permutations. Well, I did. I did 7 permutate 4 at a time. I did 7 factorial over 7, over 7 minus 4 factorial, which is 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1. Cancel, 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 cancel. Oh, same thing. Here's the cool thing. I don't actually need the formula. I love the formula, but I don't need the formula. I just draw little boxes and say, well, I got 7 choices, 6 choices, 5 choices, 4 choices, boom. But bottom line, as soon as you see it descending by 1, chances are you're probably doing a permutation. So what the book does is they talk about ice cream. Oh, did they use the word combinations? Oh, yes, they did. Oh, that's too far long. Let's talk about something else important. Horse racing. So I got 10 horses. Okay, so 10 horses. And I want to pick 3 in a row. The exacta, the trifecta, whatever. I want to pick the horses to be in the correct order. And let's say the horses' names, like horse A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, I, and J. Say we use letters. And I'm going to pick F, E, A. And if I get them in the correct order, I'm going to win. I got one chance. Maybe, do I have one chance? Well, first of all, out of how many? So, first of all, how many different choices do I have for that horse to finish first? Well, you have 10. How many different choices do I have for the second spot? Well, since a horse finished first, 9. How many chances do I have for a horse to finish third? 8. So 10 times 9 times 8 is 720 different ways to figure it out. I have one chance for a win and 719 chances for a loss. That's what I got. So I got 1 in 720. So the probability is really low because the probability of a win is one chance, one of those orders, and it's distinct orders out of 720. With respect to odds, I got one chance to win and 719 chances to lose. So, if you start thinking that in terms of money, you know, you can figure this out pretty quick. It's not very likely it's going to happen. Bottom line, I love permutations. Permutations are easy for me. I just draw blanks, just go 10, 9, 8, answer the question. People are happy. Now this other thing called combinations, I'm not a natural at. I actually need this combination formula, which is n factorial over n minus r factorial. And you're like, wait a minute, that's the same as the last one over r factorial. Now, if you don't understand it, you just hope they ask you like 9 choose 3. You're like, I can plug numbers in. 9 factorial, 9 minus 3, 9 minus 3 factorial, and then you take that and you go 3 factorial. Now these are even more fun because 9 minus 3 is 6. You get to go 9, 8, 7, 6, 5, 4, 3, 2, 1. Now you got a 6 factorial and a 3 factorial. I'm going to do the 6 factorial over here. I'm going to do the 3 factorial over here because it doesn't matter where I write it. And then you have the obvious cancel party that you can even go farther because 8 divided by 2 is 4. 9 divided by 3 is 3. And I'm left with 3 times 4 times 7. 12 times 7, 84. Now I'm telling you, I need that. Because what I'm about to tell you is order is not important. You still can't repeat, so no repetition. Or however you sell the word repetition. But order is not important anymore. So I guess I'm going to have to explain this and just show you how bad I am at this. So you got Al, Brad, Chuck, Doug, Ed, and Frank. And they're going to form four-person committee. This might kill me. So it's just a committee. So there's these 4 chairs, and you got A, B, C, D. But just so you know, it's just a committee, so order doesn't matter. So if you got D, B, A, C, or B, D, sorry, B, D, A, C, it's a same group. So combinations help me figure this out, because I need to figure out how many committees of 4 people I can make, and order is not important. A permutation problem is really easy for me. A permutation problem is I just draw 4 blanks. This is where order is important, and I go, there's 6 choices, 5 choices, 4 choices, 3 choices. And that's a permutation problem. And it's not that, though. It's something harder. But what it is, it's 6 choose 4. Now it's 6 factorial over 6 minus 4, 2 factorial over the 4 factorial. So it's 6, 5, 4, 3, 2, 1. Do this one. 4, 3, 2, 1. Do this one. 2, 1. 4, 4, 3, 3, 2, 2, 1, 1. I find that extremely fun. 30 divided by 2 is 15. Different ways. So I could try. I said I'd show you how bad I am. Okay, A, B, C, D. A, B, C, E. A, B, C, F. B, C, D, E, B, C, D, F. C, D, E, F. Now let's skip the B when we start with A. So A, C, D, E, A, C, D, F. Okay, I got a ways to go. I told you I'm pathetic at it. I lost focus, my dog barked, and I just lost train of thought. But I don't think I'm gonna be able to do it anyway, just because my mind doesn't work that way. And you can make fun of me all you want, because some of you are probably naturals at that. There is 15 different ways. Trust me, the math doesn't lie. But just to show you one of my weaknesses, that's always been one. Without the formula, it's really hard for me. Let me go let my dog in. What's his name? Brett Favre. I'm back. What they like doing is talking about food. So let's say you're at an ice cream place and you can get 3 different flavors of ice cream, like in a banana split, 3 scoops, but there's 12 flavors. Now you know order really doesn't matter in a flow. If you got the strawberry ice cream, lime ice cream, and grape ice cream, sounds disgusting. But technically, the order doesn't matter unless you're like got serious issues. Like, and some of you may have to have the strawberry in the middle, but I'm telling you, the order doesn't matter. Now, how many different ways can you do this? Well, you got 12 flavors chosen, 3 at a time, and it's just not going to happen. I'm not going to be able to do it, but I can sure do the math. Subtract them, write the dude down. Now you're getting a little smarter because you know 12, 11, 10, 9s get canceled, leaving you with 3, 2, 1. because now I just got rid of the fun stuff, 9 to 1, 9 to 1, cancel, 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 cancel. But 12 divided by 3 is 4. 10 divided by 2 is 5. 20 times 11, 220 different ways to get 3 scoops of ice cream with 12 flavors. Okay, I mentioned this earlier. When you play poker, now this is 5 cards you got, and you're sitting there with the 5 cards in your hand, and you got your hand, here you go. And or maybe you got both hands. Here, let's draw 2 hands. And you're moving the cards around. Well, guess what? You can move your cards around all you want. That's your hand. The order in your hand is not important. Even though some people, they arrange their cards and they arrange them again like they're creating a new hand. I don't know what they're doing. Just hold your 5 cards there. That's your hand. So the order's not important. But there's 52 cards. Choose 5. Now that's 52 factorial over subtractum 47 factorial and write it down. That's 52, 51, 50, 49, 48. This 47 kills off this 47 to 1 over 5, 4, 3, 2. Now, if you do your math, you do get 2,598,960 different 5-card poker hands where the order doesn't matter. Now, it's even more complicated than that because after you get your cards, somebody's going to say, well, you can, I would like 2 cards, and you set 2 down, making things way more complicated than just dealing them. And by the way, you can have a little fun with this. I just know the answer, but it's not like 50 divided by 10 is 5. Here's 12. 48 divided by 12 is 4. And if you go 52 times 51 times 5 times 49 times 4, that's what you get. That many different poker hands. A lottery. Suppose you play the lottery in which the winner is chosen by drawing 6 balls at random from a drum containing 52 number balls. What is the probability that your 6 numbers will match 6 winning numbers? You guys know the order in which the balls come out don't matter in a regular lottery, so it's clearly a combination problem. So you got 52 balls. I don't know why they chose 52, like the same number in a card deck, but okay, let's say there's 52 numbers. What is the probability that your 6 numbers will match? Well, choose 6. Now I'm not going to play I'll play it. 52 factorial over subtractum 46 factorial, write it down, and I copy it right out of the book. So what is the probability of a win? 1 chance in ouch, 1 in 20 million. Okay, I think I'm going to end the lecture here because it's a probability and coincidence section that is really, really way underdeveloped here, and I'm going to just decide to avoid it when I'm assigning your problems. If I feel like coming back to it, I will, but it's so specific, I don't think by doing it we're going to actually retain anything. Also understand that you know, some of you may want to take a probability or a statistics class. They spend a lot of time on this. We do like 10 problems, but in a regular class, you could do 30 or 40, and you could study this literally 4 times longer. You could do a little more theory. You could do a little more complicated application. You could do mix between combinations and permutations. We're just touching the surface here. Um, was I a natural at this? Well, at permutations, I am. Am I a natural at combinations? Nope, without the formula. I'm just an average Joe Schmo. So, anyway, that's it for now. Section 7E. Um, by the way, we're going to take a 6-7 test, and I'm going to create the 6-7 test. And I think as of right now, I plan on lecturing over a little 8A and a little 8B. And we're then pretty much at the end of our curriculum. I'm going to double check with the department, make sure that's all good. And if we got time and I want to cover some other sections, it'll be mostly a little more for fun, maybe just a homework section with no associated quizzes. So that's it. I'm going to get all this stuff posted and turn you loose.